Hi, everyone. My name is Jess Larson. I am meshIQ's events manager. meshIQ and TXMQ present today's Tech Talk, Mastering Streaming Queues in IBM MQ. Just to let you all know, this Tech Talk is the fifth in a series of Tech Talks that meshIQ will be presenting bi-weekly. At the end of this presentation, I will include links to watch past Tech Talks on demand. Also, feel free to send any questions you have in the Q&A chat box throughout the presentation for the Q&A portion. I will now pass it over to Art Rodriguez, a Senior Solutions Architect at TXMQ, to introduce our presenter today and host the Q&A at the end of the webinar.
Good morning. My name is Art Rodriguez, and I'm a Senior Solutions Architect at TXMQ. TXMQ is a full-service IT solutions development, consulting, and staffing company. We work with clients from enterprise to startup, helping them realize their business goals. TXMQ offers technology, consulting services, staff augmentation, project-based solutions, as well as customizable and offshore development solutions. On behalf of the teams at meshIQ and TXMQ, I would like to welcome everyone attending today. We appreciate you taking the time to join us for the Mastering Streaming Queues in IBM MQ webinar. Our presenter today is meshIQ's Vice President of Development and Support, Richard Nikula. It is my pleasure to introduce Richard to you today. He and I have collaborated on several projects over the many years we've known each other. Richard is a highly skilled technologist, a creative thinker who delivers practical solutions to complex problems. With over 37 years of experience, Richard is a fixture in the MQ community. He is responsible for meshIQ's global development organization, including Q&A and support and services. An integration and observability expert, his work spans mainframe and distributed computing, including IBM MQ, CICS, all cloud infrastructures, and everything in between. Over to you, Richard.
Thanks, Art. All right. Thanks for that great introduction. Appreciate it. Again, I appreciate everybody joining today. And let's go ahead and get into the meat of the presentation. So just a little bit about meshIQ and why we're here and why we can talk about things like streaming queues with MQ and how they're pertinent. And the key is that meshIQ is an observability platform for messaging, event processing, and streaming across the hybrid cloud. That's the origin of our name, meshIQ. And that really covers all these different technologies that you can see here, and they fit different roles within the modern messaging environment. And so, messaging being sort of fundamental to all of them, today we're going to, focus specifically on the MQ part of the messaging mesh. The mesh and meshIQ allows us a lot of different angles, and I'm actually going to use several of these today as we go through and demonstrate how how streaming queues work. You'll see us using, facilities from our governance, our intelligence, and introspection, as well as the ability to take actions in that. So within the mesh. So we will demonstrate a bit of all of these today. So a quick history or a view of the agenda. I'm going to start by just giving you a quick summary of what it is that streaming queues do, then discuss how you would set them up. And then I'm going to go through some use cases, specifically, how you would use these in your environment in different use cases. Maybe using it to create an audit trail or to change the workflow, or maybe even getting insight into your messages within the environment. So streaming queues were released originally in 2021, part of the continuous delivery release for IBM MQ 9.2. Specifically, it was 9.2.3. Now, the continuous delivery is a mechanism that IBM MQ uses that allows them to deliver new functionality without breaking the main code base in case something should happen. And so basically they have long-term support and then continuous delivery. And the long-term support version 9.3 in June of 2022 was the first time most customers got at least the ability to say, well, all of our queue managers can run with this, where maybe from a testing perspective back in 2021, you could have tested it. And then even as recently as October of last year, they released an update as a CD release, but this time to allow support for shared queuing on ZOS. So depending on which of those applies to you, bottom line is today, most of you can at least take advantage of streaming queues. One interesting thing is we recognize that there was a lot of power in streaming queues, and I'll show you some of that as we go through today. And we've supported them right from the get-go. When they first came out, we've had the ability to support them. So what was the need that streaming queues filled? Well, specifically MQ, if you go back, to its origin, it served a very specific functionality. It was allowing applications to communicate with each other in ways they never had before. But that was pretty much a point-to-point communication. And that was great because it solved a really good problem. But as time evolved, new requirements came in, and it was hard to adjust for those. Now, you could throw a broker in there, and that would be another solution to this. But that was kind of a complicated way of solving this, right? And the real problems you had were things like the applications were hard coded. Not everybody thought far enough in advance to allow for a loosely coupled environment. Now, we work with customers that have aliases for every queue, right? No application, for example, ever puts to a real local queue. They put to an alias, they get from an alias. That's pretty flexible. You do that, you can rewire things pretty easily. But not everybody thought of that when they originally created their environments. Similarly, the applications themselves, you could have changed them. We can go out and we can change the name of a queue, but gosh, that's pretty hard because again, the applications probably didn't think about externalizing that when they wrote them and saying, I can allow somebody to overwrite the name of this queue, right? So they didn't allow for that either. And you could create topics. That was another thing that came around and you could do it. But that meant changing some of the behavior of the applications and adjusting or, allowing for, different conditions that applied. And that, again, was not a feasible solution. So people were looking for an alternative, for something to address that. And that's where streaming queues come in. So a streaming queue is basically a copy, right? It allows you to make a copy, as the picture sort of shows at the bottom. Instead of the message coming in and only going to one place, we basically take a copy of it and we send it to a new queue, right? So we stream that queue over to a new queue. And that queue could be a local queue. It could be an alias. It could also be a remote queue or a topic, right? So it allows you the ability to basically make a copy of that message and send it to some other place, right? And for a queue specifically, it's virtually identical to the original message. So you can, anything that's in there, and I'll show you that, is sort of the same in both the original as well as the new message. And there's a couple fields as mentioned here that aren't copied, and we'll see that through demonstration. Topics, on the other hand, because of just the nature of topics, they create a new message when it's published. So it's not a copy of the original, but the data and everything else is the original. And certainly the goal of this is that the applications are not aware that there's a streaming queue even involved, right? So that's certainly our goal. So that's part of the value of the streaming queues. There's a few limitations and some caveats. For example, you can only stream to one queue or a topic, right? So this is not the ability to say, well, okay, I want to make 5 copies of that message and send it to somebody else. If you want to make 5 copies, well, then you have to use a topic, right? In which case, then you could have 5, people subscribe or 5 subscriptions to that topic, right? But at least it's more valuable than you had before, where you didn't have any. Now you have at least one source to send it to. Multiple queues can actually stream to the same destination though as well. So it's not one-to-one. It could be, you could have 5 queues that all stream to the same destination. You can't create chains, so you can't have QA streams to QB and QB streams to QC, not allowed. You can't actually create a subscription that points to a streaming queue. And again, that's because of the nature of how subscriptions are set up. You can't define streaming queues for most of the system objects. So it's only for application queues. You can use cap expiry, and I'll actually show an example of that in a bit. And there's something called best effort and must duplicate. And those determine what happens when things don't go the way that you want. Okay, so let's go ahead and shift gears now and look at this in a little bit more detail and through some examples. Okay, and I'm not going to use a live demo today. I apologize for that. I'm going to go ahead and use a canned demo, but all of this sort of demonstrates the features. And one of the things that it allows me to do is, of course, to zoom in and do some other things here on the presentation. So that's one of the advantages of this. And so I just wanted to start off with a typical MQ environment. And the thing that I wanted to focus in on here is that this is an MQ, This is an MQ environment across a number of different environments. One of the key things about the meshIQ solution is that we allow you to see across your environment of different types of applications. So you can see on this dashboard at the top, we've got MQ, we've got Kafka, we've got different queue managers here of different versions. In fact, some of these queue managers support streaming queues, some of them don't, because again, one of the challenges is this is a relatively recent phenomenon. 9.2.3 and above are the only versions that support it. And so, some of them support it, some of them don't. That's something we take care of when we deal with the objects. We understand there are, platform differences between them. And so this is just an MQ environment. And from this view, it's pretty hard to tell that there's any streaming or anything else going on. So let's drill in a little bit more and take a slightly different view where we're actually going to look at these things from streaming perspectives. And you can see here that I've now brought in some additional columns into my view. So I now am showing the streaming queue names and that quality of service that I mentioned earlier. So it's pretty easy now out of this list of queues to see which ones have streaming related with them, right? So we can quickly spot this, and we can see, in fact, that we've got, different test versions here. Again, this happens to be my test environment. But I've got 9.2, 9.2.4, 9.3. These are actually older ones running out here. So these are different queue managers at different levels. Some of them are streaming them, some of them are not. And we'll see more about this as we go. Okay, now let's go through and do some scenarios around our streaming queues. So we're going to take those and just do some examples with them. So the first one, I'm going to go ahead and put a simple message to one of our streaming queues, one that's been set up here, this stream process out, that has a streaming queue associated with it. And I'm just going to put a message, and it's just a simple little simple XML message here. And if I do that, you can see, let me zoom in again. Oops. That now our original queue has one message, as well as the streaming queue has a message. And if I go down here to the bottom, you'll see that, as I mentioned originally, these messages are virtually identical. We're looking at both messages here. The message ID that was generated is still the same message. the put date and time is the same. So technically, these messages look identical. It's hard to tell from the outside that there's any difference in those two messages. Okay. Thus, I've now demonstrated the key objective of a streaming queue. But let me change the scenario a little bit. So in this case, I'm going to go ahead and I'm going to specify an expiry for my original message. So I'm just putting a test message here, and I'm going to set this one to expire in a minute. Okay. And when I do that, and I now look at the two messages, and I now look at the two messages, you can see, in fact, that the new message that I put to the streaming queue, or sorry, to the original, the process out queue, is going to expire in about a minute, right? So that one is expiring, but the one sent, the copy sent to the streaming queue, has no expiry. Now, why would you want to do that? Well, the main reason is, let's say that, one of the use cases we mentioned was this was going to be used for an audit trail. Okay, so you don't want the audit trail to go away in 60 seconds like the original message did, right? So that wouldn't be a very useful audit trail. So by setting your expiry time up, the default to not expire, then that becomes an audit trail that is good for forever. Okay. And now, of course, we can do the opposite scenario, right? So we can set the expiry on the queue itself. Now, this happens to be a 930 queue manager. So for some of you thinking, well, gee, I think cap expiry has also been added as a real parameter now. I don't have to do it with custom. Well, the answer is that was introduced after 930, and thus that is not available in this queue manager because it's a 930 version queue manager. But again, for the point of demonstration, either way of setting cap expiry, I'm now setting it on the stream queue. So the name, again, if I use this streaming name, that's so that's the one that it's streaming to, right? So I set the cap expiry on it, okay? And so now if I do the same scenario I did, I put our test message, and now I look at the results of those test messages, you'll see that it's the opposite way, right? That, it does actually expire in 60 seconds, just like the original, because both of them now have an expiry. Well, why would you want to do that? Well, again, if you're trying to actually, emulate a copy of that message for, another part of the application, then for the same reason, you want it to expire when that message, when the original expired as well. So a lot of flexibility in that. So just, as some very simple examples of how we can use some of those settings to our own benefit. Okay, so our first use case, again, just elaborating on that same one that we just did, we're going to do message duplication, right? So we're going to end up with multiple messages out. Okay, so again, I'm going to work with a set of queues. There are these set here called credit queues, and they're just a sample application that I made up. It doesn't really serve any other purpose than that. Okay, and I'm going to go ahead and I'm going to switch this up to be best effort. Okay, so this was one of the settings that we talked about, this quality of service. So I'm going to set it to best effort. Okay. Now I'm going to go ahead, again, I'm going to put that sample message. And when I did that, it worked just fine. Oh, sorry. Actually, I just realized something. I forgot to tell you one key thing before I started. Let me go back up here. Okay. So let me zoom in here real quick. You might notice in the background that these queues, in fact, let me go back even one more slide, because I was building a story and I forgot to tell you. That's right. These queues are getting full. Okay, so this queue, for whatever reason, only has a max depth of 5. By setting it to best effort, I'm telling that the queue manager, if it can't complete this exercise, what does it need to do? So I'm going to put this message And you'll notice that in this particular case, that this queue now had 6 messages. So before I did it, there was 5 in both. This one now had 6. This one still has 5. And the reason it still has 5 is because the max depth of this queue, and it's is 5, and the messages that I would have put it over the limit, so it wasn't allowed to put that message. But because I used best effort, I didn't have to deal with that. Now let me do the same scenario, but change it to must duplicate. Okay. So in this case, I'm going to say that it has to duplicate that message. And when I do that and I put the same message, this time, this time I get that queue is full. Okay. Right. So before, you can see up here now, it's a little easier in the background. You can see the current depth of the queue was 5. This one had a max depth of 5,000. It's fine. The streaming queue had a current depth of 5, and the streaming queue had 5 already in it. So in this case, when it tried to stream, it actually got a queue full message. Okay. Now, I mentioned originally that there was no need for the applications to be aware of streaming queues. This is one sort of caveat from them. In this case, the application queue was not full, right? If somebody were to say, gosh, I put the message and it came back and it said that, that my queue was full. Well, it's not really true. Their queue isn't full. It's the streamed queue that's full. So in that particular case, you actually would have to go look in another place and know that there was streaming involved if that occurred. So there's a little bit of application knowledge. Now, again, that could also apply to, get in or put inhibited, to security errors, to, any kind of other error. The key is if it doesn't go to the streaming queue, then the application will get a return code if you've specified that must duplicate. So generally, if you're not going to, create a real flow in the application, then the best effort is the best approach. But speaking about the events, and I'll actually show that here, I'm now drilling in and specifically going into the events. And if I go to the stream queue, you'll see that the stream queue was the one that actually got the queue full event, right? So we can see here now that we got a queue full event, but we only got it on the stream queue. You will not find one for the credit process out queue, even though that was the queue I put the message to, or the application put the message to. It's not the one that generated the queue full. It was the streamed queue. And then since I brought it up, I thought it's a good time to introduce the concept of the system queues that you can alias. So it turns out that all of the event queues are aliasable or are configurable with stream queues. So one of the problems that have been around since day one with MQ has been that the system queues were kind of a single resource. So if you generated it, like in this case, a queue full event, it was sent to a system event queue, but only one application could read that message without having to do, some sort of, sophisticated logic. So you wanted this, but that was usually the case. There were lots of people who wanted to have access to the event queues, right? So, different monitoring products or your own applications or, you name it, they all wanted to have access, but only one of them could read it. And so there were different techniques for that. Well, now with streaming queues, you can see that I went ahead and created a meshIQ event queue as a stream queue for that. And so the original messages are still sitting out here on the system queues, and we get a copy, right? So this allows us to get a copy. That's how you saw that event in our, in our GUI, is we made a copy of the original event. We stored it so you could see it. And so again, that's another use case for the value of a streaming queue. And you can actually see down here in this last one, I actually sent it to a topic. And the reason I sent that to a topic is I had multiple consumers of the statistics. This happens to be your IBM MQ statistics. And again, a very common scenario is you might have multiple use cases for that. So again, I've sent those to a topic, which allows me to then distribute it to multiple additional applications, right? So a lot of value in that. And this really demonstrates, how you can use streaming queues to your value. The other thing I thought I would point out is that on this particular screen, you might wonder, well, how did I get this list? I didn't, I've been showing all these different things. How did I get a list of all the streaming queues? Well, it turns out that we have the ability to create attribute filters. And so I created an attribute filter that said, go find all the streaming queues. So again, this was across my entire environment, which again, pretty simple, but imagine this could be, your entire environment, all of your queue managers, whether they be, Linux, Windows, ZOS, AIX, appliances, you name it. I want to just know where all my streaming queues. I can bring that one list up here on one screen. I don't have to go hunt for them or anything else, which is what's the most common thing that most people have to do. They have to go find all of their streaming queues and go look in different places. So again, the value of the meshIQ solution. Okay. So second use case is around message redirection. Okay. Now, this is a very similar use case. The difference is, what am I doing with that message? In this particular case, I'm going to actually take that message and I'm going to read that message with Kafka Connect and forward it on. Okay. And to do this one, I did a slightly different use case as well. I'm going to use a developer user. Up to this point, I've been using more of an administrative account. I'm going to go ahead and demonstrate what a developer might see on a test system when they were, trying to use streaming queues and see how they would, how they might operate. So their view is a little bit different. And there's a lot of differences actually in this particular view for the user. The first off is he has one dashboard, unlike my admin account that had Kafka and MQ and other things. They just have one dashboard and it has Kafka and MQ on it, right, sitting beside each other. And they don't even know and aren't even worried about what's the name of the queue managers. I know that's something an administrator might worry about, but yeah, they use Kafka, they use MQ. They don't really need to know where, they just need to know what their topics and queue names are, right? So they've got their own sort of little view here, and they, the way they look at the things is customized to them and so on. And for this scenario, it's still streaming queues. We're still looking at our same old credit queues, but in fact, their view is limited to just the credit queues. And unlike the admin user where I kept filtering it down or subsetting it to show you the credit queues, they don't get to see anything but credit queues because that's all they're allowed to work with, right? So that's the meshIQ security model tying in this scenario. And so here's our queues. Of course, we're going to take one of these queues and we're going to turn it into a streaming queue. And we're going to go ahead and that'll be this credit input error queue. And we're going to go ahead and put a message to that queue. And when we do that, the important thing to mention or to note here is I now went into the Kafka resources. So you'll see I'm actually, let me zoom in here, right? So let me zoom in on the top first. So we can see here that here's our credit input error queue, right? And we put a message in here, right? And so we've got our message there. But if we come down to the bottom and we look at our Kafka topics, we actually see the result of the messages are also here, right? So we've now validated that the messages actually transferred over. And if we come down here, we can actually see the same message that we just put on the prior screen. So that's as simple of an example of integrating with Kafka as you can get, right? I created this as a streaming queue. I took this streaming queue. It's being read by the Kafka Connect component. And then I'm now viewing it sitting over here in Kafka, sitting in a Kafka topic, right? Now, again, that could be an audit trail scenario, right? Why did I want to move it? So unlike the original example where I said, well, I could put it to an MQ queue with an unlimited expiry, it's still sitting on an MQ queue. That might not be where you want your audit trail to be. Now, you might want it to go to a database, and of course, there are database connectors for MQ, right? My particular case, I said, okay, I'm going to throw it over to Kafka. Kafka is a great resource for keeping a lot of messages for a longer period of time, right? So it was, it demonstrated that. There might have been, it might have been a Kafka application as well that ultimately is going to read that message. But the key is, we've now taken an MQ message that originally had no destination, was not targeted to go to Kafka in any way, and we're now consuming it in a Kafka environment. Okay, one last scenario here, and I call this one message intelligence. And so what we're going to do is we're going to take this copy that we've created, and we're going to send it out to meshIQ analytics. Okay, so this is our own tooling, and I'm going to consume that. And again, doesn't have to be ours, lots of other scenarios where you could do this, but the concept is going to be the same for all of them. Okay, so what are we going to do? Well, obviously, we're going to start with the same old queues. Everybody's figured that out by now. I really love to have these things called these credit queues, because I'm not very imaginative, but it's the best I can come up with, right? So we've got these credit queues, and we've got them set up so that we can stream them, right? Now, in this scenario, I have a specific use case in mind. This one here that says credit process process order detail has an application that's reading that queue actively, right? So any message that gets put to credit process order detail is immediately read by an application. So if I were to ask the question as to, well, gosh, I wonder what messages are coming in for orders right now, I'd really have no way of doing anything with here. I can't go browse that queue and look at it. If I were, there would always be no messages on the queue. So I can't really look at that way. So I'm going to use streaming queues to do that. I'm going to do this a little differently, though. What I'm going to do is I'm going to go ahead and I'm going to create a streaming queue for that, but I'm going to set it to best effort, okay? And I'm going to go ahead and leave the maximum depth of 5,000 messages, okay? So now I've got a streaming queue. I've got best effort set, and it's going to go to this credit process detail queue. Oh. There we go. All right, and now I've waited some period of time, and you can now see that this stream queue has 5,000 messages on it, right? So I've now gathered 5,000 messages from the order detail queue. The original messages still flowed to the original application just as expected. I didn't have to do anything to that application. It doesn't even know that I've now, sniffed 5,000 of its messages, okay? And that's why I used best effort, because once I hit the 5,000 max, I was done, right? So now I can go in, I can go turn it back off. I don't need to leave it there anymore. It was strictly for the scenario of I wanted to sniff for a period of time, gather some messages. So I've now gathered my 5,000 messages. So now what I'm going to do is I'm going to run that into an analytics. So I'm going to run our analytics against this credit process order stream. And I'm going to take those and I'm going to push them into the meshIQ platform. And this is just looking at those raw events. So this is the 5,000 orders that I happen to pick up. And an interesting scenario for this is, in order to do this, I just went out to the web and I said, I just like some sample data. I found a file with had 500,000, but I limited it to 500 or 5,000 for this demo. I said, go grab that CSV file and import it. I'm just going to put it to a queue. And that's all I did. I mean, that was where my data came from. So I really didn't know much about the data when it started. But I did figure out by looking at it that it had an order, it had a name, it had a province. Apparently my data came from Canada. It had some sort of a product code with some prices and other information, right? And you can see I sort of grouped these out here and there. Now, I learned that simply by browsing the data that went into that queue, right? And now if I take one of those, and so like, for example, what if I drilled down on this bookshelf and said, did anybody else buy bookshelves? And sure enough, I can see that in fact, all of these different orders came in for bookshelves, right? And they paid different amounts and whatever. I get that visibility. So I'm using the fact that I could use that streaming queue to suck off some of the data. And now I'm analyzing that data to say, well, what happened? And now I can do some other things. I can group that data and say, well, there's this thing called classification, which is like, what type of thing was it, right? And I can group by that. And that's pretty cool. I can see, oh, wow, I got lots of different things, right? And then I could say, well, that probably look better as a pie chart. So now I've looked at it as a pie chart and then, gosh, gee, I see this is cool, but gosh, there's a big chunk of it that's others. Maybe I want to be a bit more fine-grained than that, so I can tweak it a bit, and now I can get in it. And now I've got a pretty good view. This is this is an analysis of the data by type of thing that people are ordering for those 5,000 records. So I've got insight into my data that I wouldn't have otherwise been able to achieve because I couldn't see the messages flowing through that queue to begin with. Now I could group it other ways. I could group it by province because again, like I said, it was Canadian data, so I could see which provinces are ordering. Or it happened to include price. Well, if I sum the price and I group it by product or by province, I can see where most of my orders are coming from, right? So again, I can see that, gosh, I got to be nice to those people in Ontario because, gosh, they spend a lot of money compared to everybody else, right? So, and I didn't even know there was a Nunavut, so I learned something new on that. So, just by analyzing the data, I learned stuff, right? And that's the key thing. MQ is kind of black box. I didn't know what was flowing through that order detail queue. But now I actually know that, gosh, the people in Ontario order a lot of stuff from us, right? So that was really the summary, right? So quick summarization, right? What did we see? Well, we saw how quick and easy it was to set up a streaming queue. We saw some of the different scenarios, how to use, the expiry time to your benefit, how to make sure whether you're using best effort or must duplicate to control what happened when the streaming couldn't occur. We saw how to create an audit trail, how to replicate a message over into Kafka, how to suck that data out and put it into an analytics engine, and so on, right? So several different scenarios, all very quick and easy, leveraging that data that was available from the streaming queues. Okay. And with that, ready to open it up for any questions.
Okay, so we've got Nathan, and the first question he asked is message IDs have always been unique, well created, etc. Would the fact that the message ID is duplicate on the stream cause issues?
Okay, good question. So the answer is yes, maybe, or not, then again, maybe not. So the first thing is actually an interesting thing. Message IDs do not have to be unique. MQ does not require that. They can all be the same. That's the first thing. In fact, we demonstrated that they were duplicates. They're typically follow an application pattern. The main reason for having a message ID on the outward side is so that when you get a response back, that the application can, recognize the message that's coming back. since we duplicated it, it's not likely going to make its way back into the application. So that, that sense, it wouldn't be a problem. If you use that in any other place, so, some people, like you say, they do think it's unique. They might have used it as a key to a database record or something, then yes, obviously, then if you tried to store both messages in there, it could be a problem. But again, since this really is intended to be new function, it typically isn't going to be not going to cause a problem in that application.
Nathan's follow-up to that is that customers have always asked many times, is the message unique? So how does this fit into the uniqueness of the message?
Well, and I guess I would still say the same thing. MQ has no requirements to have unique messages. I can, in fact, send the same message myself. I could do that here as a demo. I could actually send the same message a dozen times in a row, and actually MQ would accept it gladly. What makes it unique, again, is more of the behavior to the application. So again, I don't. It is an MQ message ID or the message itself is not unique in its own right. It's unique from the application perspective. MQ will not duplicate the delivery of a message. If you duplicate the message and send it twice, MQ will deliver both of them. So, but we can drill into that more offline, perhaps, if you had further questions into that regard.
And then the next question, normally Q attributes cannot be changed without a restart. So I'm assuming that changing the streaming options must also have a restart.
There is no restart required. I showed you the scenarios I did. Like I said, I even changed it to a running application. As soon as the Q definition changed, the behavior that MQ picked up from it changed as well. But it would affect the application. You're correct. I think the follow-on question is obviously if from the application's perspective, it would not be aware that there were any changes made to the queue. But the definition itself would have changed.
Oh, here we go. Will it duplicate the MQ RFH2 to the streaming queue as well?
That's just part of the message, yes.
Are there any performance implications to using the streaming queues? Does it impact the queue manager or the memory allocation needed, anything like that?
Sure, that's a reasonably good question. Everybody's always concerned about that. So the answer is yes, obviously there's an additional message being put, right? So there is some performance implication. It's one additional put. So again, so obviously if you're putting, 1 million messages a day and you turn on streaming, you're putting 2 million messages a day, right? Is that going to be, significant? Well, again, that would be up to you and your application. So that's the main overhead. I mean, it is basically as simple as, and again, if the messages are persistent, then obviously there's recovery logs and all that have to be, involved and that as well.
So from my own experience, streaming messages is usually pretty high volume, data pipelining, that sort of thing.
Sure.
So I think most likely a lot of thought needs to go into just what your message volumes are going to be.
Of course.
So that you make the settings when you set the queue manager up, and that's
sure.
So there are performance implications, and it needs
sure.
to, it needs to be part of your initial design.
Sure. No different than if you did originally said I was going to do 1 million and now you're going to do 2. Yep.
What happens if the application fails and the original message is backed out?
Right. So so that's actually kind of tied to why it probably came up because I mentioned persistence. The answer is then the copy is backed out, right? Because they're put under the same unit of work.
Have you tried using production streaming queues to load into a test queue for replay purposes?
You could do that. I mean, again, but again, keep in mind that this is it's not really a replay. So you'd have to load them into the original queue as well. For something like that, we actually have an unload reload function. That's what we would have used. I mean, you take those messages, write them out to a file, and then play them back from the file, not from a streaming queue. And yes, the next one, you could define a streaming queue as a remote queue as well. That would be supported. You could remote queue from one other to a local queue on another source. Yeah,
that's cool. Does the message to the streaming queue inherit the persistence of the original message, or is it always non-persistent?
Yes. No, it's going to inherit whatever the original is, and in fact, that's one of the attributes that's ignored on the streaming queue. So if you had default, say you had default persistent on the streaming queue, but you sent a non-persistent message, it would still be non-persistent, and vice versa.
Okay. In another video, meshIQ TechTalk, you demonstrated a similar concept using MQ activity trace events. How is this different?
Okay, right. So that was talking about analyzing the data, right? So from an analytics perspective, the data can come from anywhere. So in the scenario that we did, I used, I just sniffed the raw data off of the queue. An activity event also allows you to sniff the data. So the difference is, in the case of the activity event, it's tracing the application calls. So an activity event, you do a put or a get of a message, and that creates an activity trace event. In the scenario where I streamed the data, I streamed the messages as they arrived on the queue. I did not involve the application. I don't know if they were ever read, and obviously in my case they were, but they don't have to be read by the application. So one, you're tracing the application, one, you're tracing the data flowing through a queue. They both collect the same raw data, so the answer is they both could be used to do the analytics. But the activity trace events actually allow you to see, like, when did the message get put, when did the message get read, what was the application calls, all of that. So it's a similar scenario, but with different criteria as to what you're doing. One is tracing applications, one is sniffing messages. Okay.
Any idea how the performance throughput of MQ streaming queues compares with other products that do message streaming, high volume message streaming?
Well, again, MQ is very efficient at messaging. So, you're not going to find many, obviously, modern techniques, Kafka, Pulsar, things like that are very, very high event streaming techniques. MQ is very good at message processing. So from a pure perspective of, I'm just, sucking MQ data out and putting it to a new source, it's going to be very, very efficient. But I think that's one of the reasons why, things like, the example of streaming it over to Kafka or streaming it over to, to any other application is very powerful, because that introduces the ability to use those new applications and some of the facilities they provide in conjunction with your existing MQ applications.
Nathan made a comment that he thinks that streaming queues would be defined as remote queues primarily in the test environments rather than in a production environment. And I mean, I can kind of see his point. I could see making good use of it in the test environment. And if you did have a use case in production, you'd probably
so you're right. So
then first anyway.
Right. So in the scenario we were doing, right, instead of streaming the results to a queue on production, we would have, maybe we would have a general purpose sort of remote queue definition that allowed us to turn, to send data over to some other system where it gets analyzed. keeping in mind also that, you, as I mentioned, you can have multiple queues streamed to the same, destination. So again, if you were going to, you don't have to have like a one-to-one kind of thing. So lots of scenarios. Again, I think that's the key. And that, again, the goal of this particular scenario was trying to demonstrate the value of how you could use streaming queues and what other things they could provide. Okay, good.
Any further questions?
I think we're good. All right, back over to you.
All right. Well, thanks again for joining us today. We encourage you to reach out to the teams at meshIQ and TXMQ if you would like to learn more about how you can improve meshIQ. Incorporate meshIQ into your application suite. I'll pass it over to Jess to wrap it up.
Thank you, Art and Richard, for your presentation today. So we will have this Tech Talk available on demand, posted on the meshIQ website following this call at www.meshiq.com. Also, please note this webinar is part of a series of Tech Talks. We rotate the topics and really try to focus on different middleware technologies. We would love to have you join again, so please be on the lookout for our next upcoming webinar around mid-May. Thank you for your time today and have a great rest of your day.